Hi to everyone. MEM School of Engineering, Department of EEE, online classes, subject digital logic circuits, unit number 2. So last class we discussed about basic adder and subtractor circuit design and multiplexer, that is many into one, that is a data selector uh, and its types, like that we discussed. Now we are going to discuss about demultiplexer. It is opposite of multiplexer. It is a data distributor. Okay, so input is one, output is multiple output. Okay, for example, if we are giving one power supply to the unit, means we are going to divide that power supply to the multiple number of output with the particular time period. Okay, for example, if you connect the power supply to the input, so output is 7 light, means you are going to on off the light. With which light I am going to on, like that. At a time we are going to on the one light. That is the concept, that is called data distributor. A demultiplexer basically reverse the multiplexing function. It takes data from one line and it distributes them to given number of output lines. For the reason, the data demultiplexer is also known as a data distributor. So single data input lines, some select line less than the number of output line, several output line, that is 2 power m is equal to cn. Same as here we are using select lines. Okay, so last one, uh, in multiplexer, select line is used for which input I have to select. Here, which output I have to select, like that we are discussing. Which output we are going to select, like that we design. That is a 1:2 demultiplexer. So 1:2 demultiplexer means we have enable pin and D input and S0 and S1. Okay, that is sorry, one select line and two outputs. So if S is equal to 0 means the input will connected with the output Y0. When S is equal to 1 means the data input connected to the output Y1. That is 1:4 demultiplexer. Here we are using two select line 0, 0, 0, 1, 1, 0 and 1, 1. So that is, if 0, 0 means D0 will get the output, 0, 1 means D1 get the output, 1, 0 means D2 will get the output, 1, 1 means D3 will get the output. So this is the difference. Same as 1, 1 is to 8 also. Here we are giving the 8 outputs. So truth table for 1 is to 8. Okay, that is D0, D1, D2, D3, D4, D5, D6, D7 and D will up to D7 only, because we start at D0. So using demultiplex tree, that is, if you design a 16 is to, sorry, if you design 1 is to 16 means you can use 4 is to 1 is to 4 demultiplexer with 4 times. So like that we can update the demultiplexer tree. So like this. Okay, then main advantage of mux and demux. Okay, that is implementation of logic function using multiplexer. That is, for example, f of a comma b comma c is equal to a bar b bar c plus ab. A bar b bar c plus ab. Okay, we are giving the input abc. So output is 1. So that is, for this particular output will be only 1. Okay, that means we are giving the 1. For example, for input 1, for input 7. If we are selecting some values, triple 1 means that 1 will connected with the output. 1 will connected with the output. You know that concept. So this is the input ABC. Okay, we are connect this input to the particular given output. Okay, for example, 0, 0, that means it is connected with the ground. Okay, if it is 1 means, so this will connected with the plus 5 volt. Okay, that means the plus 5 volt connected with the 6 and 7 also. So these are connected with the, these are, sorry. So these are connected with the ground. So this one will given to the, this connected with. So this is the concept. Okay, when we are selecting the value, for example, 0, 1, 0 means it will select the this one, that is third one, that is 0, 1, 2. Upper 0, 1, 2 connected with the output, so output will be 0. So this is the implementation of logic functions using multiplexers. This is the another example. Okay, these are the implementation of MUX. So next topic, next combinational circuit is encoder and decoder. So encoder and decoder basically converts n number of input into n number of output. Okay, that is the concept. Encoder and decoder converts n number of inputs into m number of outputs. So in MUX and DMUX, we have any one of the input or output will be 1. Here they have different numbers. For example, 3 input, 8 output, otherwise 8 input, 3 input, like that they have. Mainly it is used for code conversions, like that they are using the encoder and decoders. Okay, first decoder. A decoder is a combinational circuit. A decoder accepts a set of inputs that represents a binary number and activates only that output corresponding to the input number. So all other output remain inactive. Okay, so there are 2 power n possible input combinations. For each of these input combinations, only one output will be high. So all other outputs are low. So some decoder have one or more enable inputs there that are used to control the operation of decoder. So that is decoder n input, m output. So one first example is 2 to 4 line decoder. That is block diagram of 2 to 4 decoder. That is A and B are the inputs. So number of possible input combinations are 2 power 2 is equal to 4. If it is 2 means output will be 2 power 2. If 3 means output will be 2 power 3. That is the concept used in the decoder concept. Here inputs 2 input. So we are using the 4 outputs. Okay. So that is the concept we are used in the 2 is to 2 to 4 line decoder. So next one, Boolean expression for this line 4 to decoder. That is 4 output. Okay, you got to draw 4 K maps and 4 output. So logic diagram, that is A bar, B bar, like that we are defined. So 3 to 8 line decoder, that is block diagram of 3 to 8 line decoder gave. So ABC are the inputs. A number of inputs is equal to 3. So number of possible input combinations are 2 power 3 is equal to 8. So that is 3 to 8 decoder. So that is A 0 to 1 1. So particular 0 means output will be 1. So for the remaining value will be like this. So output like that you can write for the concept. If D is enabled means you have to put A bar, B bar and C bar. Okay. So logic diagram of decoder. So that is D0 is equal to A bar, B bar, C bar. So like that we are defined. Same as 3 to 8 decoder. We can derive from the 2 is to 4 decoder. So this is the implementation of uh, Boolean functions using decoder concept. Okay, same. For this particular output, it will be 1 like this. Okay. This is a decoder concept.